Mr. Ray Ellis, co-founder and vice president of sales and marketing for Air Systems International, a company that's very involved in the world of confined spaces. In 32 years of experience, Mr. Ellis has seen far too many deadly accidents. Accidents that in most cases could have been avoided.
Dangerous accidents and fatal accidents in confined space entries are avoidable. Certainly, while some situations due to carelessness, due to lack of education, due to improper equipment, you're going to have fatal accidents. But the risk can be certainly minimized. To give you an example, AT&T was the very first organization back in 1971 to have a legitimate confined space entry program. They do on average better than 77,000 entries a day. Since '71, they've had 2 fatalities. Neither one were directly related to confined space entry, either respiratory failure or an explosive situation.
While there are many dangers working in confined spaces, one rises above all the rest.
The dangers of bad atmosphere vary based on the toxins and volatile vapors and things like that that may be present. The most important piece of confined space entry equipment next to the worker and his educational process is going to be a multi-gas monitor. The multi-gas monitor can identify the atmosphere prior to entry. It can tell the worker what safeguards need to be taken in order to make that entrance a successful one. It can monitor that atmosphere while the worker is inside the environment. So if anything he's doing through the course of his labors happen to change that atmosphere, he can be alerted and notified, and then that way take the necessary precautions to get out safely.
This is why testing is so vital to survival in confined spaces.
When the workers enter the particular area, they need to be able to also continuously monitor. This particular device has the ability to check the atmosphere prior to entry with some accessories that are attached to the side and to the bottom of the monitor, as well as once those accessories are removed, the worker can then wear it with the belt loop clip that you see here on the back and maintain continuous monitoring while they're inside the environment that they're working in. This is going to alert the worker, give the worker an opportunity to respond to the condition and then egress that particular confined space area. That's what's going to save their lives.
Proper testing will tell you what dangers lurk in the air and how to combat them.
The primary purpose for ventilation is to stabilize the atmosphere within which the workers are working. And in that process of stabilization, through pushing fresh air into the confined space area, we minimize the time frame in which the atmosphere can change. And in doing so, give the worker an opportunity to respond to the instrument and then to take the necessary steps once that response has been legislated to them through proper policy and procedure as to whether they're supposed to egress or don proper respiratory protection.
But don't stop at ventilating a confined space. It still may not be safe.
Just because you're ventilating doesn't mean you do not have to wear proper respiratory protection. And that's crucial as far as understanding. People are lulled into a sense of security that doesn't exist, because it's dangerous. You have limited entry and egress in a confined space area.
And there are other dangers too.
Static electricity is a very, very unusual anomaly. And a lot of people don't understand that static electricity can be generated. We are moving such huge and large volumes of air at such tremendous velocities through basically a conduit, the ducting that we use. Plastics act as a receiver of static electricity, and they basically store it. And at some point in time, when the storage of that charge gets large enough, it wants to discharge to a grounded source. In order to combat the issue of static buildup with regards to the ventilation aspect of atmospheric control of a confined space area, a couple of safeguards and precautions are basically need to be considered. Number one, the blower cannot be of a standard electrical design. It needs to be explosion-proof or intrinsically safe. An explosion-proof blower is an electrical device that's got a huge housing around it. So should it ignite the ambient environment that's able to get into the housing, that explosion that occurs will not ignite the ambient environment in which the blower is placed. Intrinsically safe means that that particular device in and of itself cannot cause a spark that will ignite the ambient environment.
Some final words of advice from Mr. Ellis.
On average, throughout the United States, there are a little bit better than 300 confined space fatalities a year. And the last thing in the world is that you'd want to have anybody that you know, anybody that you don't know, even if you want to read about it in the newspaper in your own hometown. There's no sense for it. There's no reason for it. A good educational program, a good training program, proper equipment, proper safeguards. The best confined space is the one you don't have to enter. If you do have to do a confined space, then make sure that you've got the proper knowledge, that the atmosphere, all the hazards have been identified. All you gotta do is just stick to the program. If you stick to the program, your chances are better than 95% you're gonna be okay.
Do test the atmosphere using proper equipment. Do isolate confined spaces before working in them. Do use protective gear, including respirators when required. Do watch out for slick or wet surfaces inside the space. Don't enter a confined space unless you are sure it is safe to do so. Don't enter a space if the permit is incomplete. Don't allow an ignition source in an atmosphere with more than 21% oxygen. Don't ignore any signs of trouble. Get out of the space immediately.